Hey folks, this is Matt with Southern Energy. We're out here on site today looking at some insulation. Specifically, we're talking about grade 1 insulation to maximize your home's performance. Let's take a look. All right, when we're looking at insulation, compression is probably the biggest differentiator between grade 1 and grade 2. In this case, we're looking at an exterior wall, and we've got some ladder blocking here. What's important is that the insulation needs to fill the wall cavity, left to right, top to bottom, and front to back, at its full measured thickness. Here, what we've got is fiberglass insulation that was cut and compressed behind this ladder block. What we want to see is that the insulation has been notched or cut. There's insulation behind the ladder block, and then we're laying a full thickness bat in on top. There shouldn't be any gaps around the blocking because it won't be in contact with the drywall surface that it was intended to insulate. As we compress insulation, we squish the air out of the material, which reduces its effectiveness as an insulation product. Compression can happen in other areas as well. We've got wires in the wall where they weren't split. So we've compressed the bat from the back side now, not allowing it to contact the back of the cavity. All you need to do in this case is split the material, put half of it behind the wire, and then lay the front back over the top, so that this area of the wall cavity is completely full at its normal value. And that's how you achieve excellent grade 1 insulation. When we're looking at the quality of insulation in walls, one of the main things we need to consider is the mechanical design of those walls. So just in this example right here, we've got gas piping, we've got electrical, we might have some pest control running through here, high-speed internet wires, all the things that folks need in their home. What's important is that we address those details when we're installing the insulation. Right here, we have what would be a grade 2, because these wires are compressing that insulation back into the bay. And when I can see that stud face, that insulation is not going to be in contact with the drywall. What we want to do is split and cut around these features to make sure that that insulation is filling the wall cavity front to back. So this is your bad example right here. But if we look right next door, we've got a great example. This bat has been neatly cut along here, split to get behind these wires, cut neatly around the electrical box to avoid compression, and laid in to fill this cavity completely. Another note is about your drain and hot water supply. So when we've got domestic hot water and water coming into the building, we've got a drain pipe. Code is going to tell us that these pipes have to be on the inside, the warm side of the insulation. And that's to avoid freezing risk. So this is one area when we're looking at the grade of our insulation where we need to default to the code values and keep those pipes on the warm side of the wall. Some of the other important framing details that we need to address in an insulation inspection are the corners and the wall intersections. These are going to be the weakest areas of the thermal wall system because there's more wood in these locations. So using advanced framing practices, we can actually get more insulation into those corners. In this case, we have an exterior corner. This is a 2-stud or a California corner that goes all the way out to the exterior sheathing. What the insulators have done here is they have cut a piece of bat to fit into that space and pre-insulated that, and then put the bat into the rest of the wall. And what we have here is a better insulated corner than we would if it were solid wood. Here's an example of how not to insulate a wall intersection. This intersection was framed with studs on both sides, and we can clearly see that there's a void behind this where there's no insulation. In this situation, we would call this grade 3 because there is no insulation present in contact with the surfaces that we intended to insulate. Another important detail is air barriers. All vertical wall insulation needs an air barrier to protect it. This helps the insulation perform at its maximum rated R value by keeping air out of these wall spaces. Anytime we have a chase like this one, where the drywall surface is not going to be in contact with the thermal insulation, we need to install a secondary air barrier to make sure that we're getting grade 1 performance. All vertical wall insulation needs to be in contact with either the drywall, Tyvek or a sheet good, or other rigid materials. The only areas where we don't need to have an air barrier on our vertical insulation is going to be up top in the band joist. All right, folks, so that's it. That's how you achieve grade 1 insulation in your walls. We just want to make sure that our wall cavities are filled front to back, left to right, top to bottom, with fiberglass insulation at its full manufacturer's depth. We want to make sure that we have 6 sides of contact on that insulation, including a front side, which could mean a secondary air barrier. We want to make sure that we're cutting or notching around all of our framing details to avoid compression. We also want to make sure that we address our mechanical penetrations and wires in the wall, and we're cutting or splitting around those as well. That's really all there is to it. We just want to see a good quality install to get maximum R value and thermal resistance out of these walls. It's not rocket science, it's building science. And this is excellent grade 1 insulation. Air barriers can be installed at the top of the wall system as well.
That's a terrible example because this
Is how did we address it? Grade 1 insulation is easily achievable by your mama.